Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at multiple or multivariate logistic regression. Now we've already seen logistic regression in the previous video. Now I do recommend that you watch that video first before watching this one, otherwise some of this won't make sense. We can see the model we did to try to identify gender, male or female, based on looking at total spend. Simply for multiple logistic regression, we have more than one explanatory variable. So what we're going to do is add a second explanatory variable, which is called recent spend, which is the spend over the last month. So otherwise it's the same as the previous example. We're just going to have two explanatory variables. So let's have a look at the code. So here's the code in HANA Studio for our multiple logistic regression. The first step, as always, is to create the model. The second one is then to use that model to perform predictions. So what we see is the difference here is that when we're creating our data, we have two explanatory variables, the lifetime spend and the new spend. And then we have our dependent variable of gender, just like before, which will have a value of 1 and 0. Everything else basically looks the same. We're calling the same logistic regression algorithm using the wrapper generator. What does change here though is in how we create our input data. So previously we were basically summarizing the sales amount for all of the transactions for each customer and calling that life spend. And what we've added here is an extra join, which is an aggregation of all the sales by customer, but only for a single most recent calendar period, which is the last month. So we can see the spend that's just been done, and also we've got a value of the total lifetime spend of that customer. We then put that together with the gender ID that we get from the customer table itself, and for the purpose of this example we're just working on the top 1000 of them, and that's our input data we're going to put into the procedure. As we saw in the previous example, we have thread numbers. For example, we can set that to 4, which is recommended, and we have the max iteration and exit thresholds that you may also want to tune and set to optimize performance and to optimize results. What's different here is that the variable num has now changed. We've increased that value to 2 because we have two explanatory variables. This is a multiple or multivariate logistic regression example. So we can go ahead and run that, and then in a couple of seconds we see that it performs the analysis on a fair amount of data, and what we can then do is refresh our list of tables, and we can have a look at our coefficients, for example. And this will be different from last time because now we see we have a coefficient value for each explanatory variable for the total spend and also the new spend, as well as the standard regular coefficient. So we can see some additional coefficients. And again, we can see that model if we wanted to do in PMML format, if we wanted to work with other software as well. So we've now created our model. What we would do next is to actually use the model to make some predictions. So again, as we saw in the previous example, we need to provide input data. So here we have two explanatory variables. So we've got life spend and new spend. We're going to input values for those, and we give it an ID. So actually, if we scroll down, we can just see we've got life spend and new spend as two variables we're going to input to the predictive model. We then use the signature file to set everything up. We forecast with, again, as we saw with the same approach as with the single logistic regression, we use Logistic R. So forecast with Logistic R. More details on that in the manual, in the PAL manual, of course. We can run this algorithm, and with these two sets of data we'll get then two results which we'll be able to identify either as being male or female. So let's run that code. It runs a prediction, applies the model, and if we now are to refresh our list of tables, we will get the RGP_predicted table, which is going to be the output from our run. So let's see, here's the RGP_predicted table we've created, and here we can see the output, and we can see both the fitted value, but also we can see what the gender is. We can see again it's been set to male for both of them. So that shows you how we can use multiple logistic regression, taking multiple explanatory variables and performing predictive analysis on that to identify, in this case, customer gender. In a more realistic scenario, that may well be trying to identify fraud based on one or more explanatory variables, or also credit scoring. So there are many, many different examples of how we could use that. So that wraps up our look at regression with the predictive analysis library in HANA.